All right, today we are going to look at different types of data that we can use in our Arduinos and also variables, so assigning values to those variables. So first of all, we are going to log into Tinkercad. So I'm going to pull this up here. I'm already logged in and I'm going to go to circuits. And I am going to use the circuit that we did last day. So it is the dual lights, so red and blue lights. And I'm going to click Tinker this. And I'm going to go into the code and see what we've got here. So we have these. Now this is set up okay, but you can see that we have these numbers here, and they're indicating which pins my different lights are hooked up to. So pin mode 7, that's this one here, is set up to my red lights, and pin 6 is set up for my blue lights. And that's fine. This is a fairly small program and I can easily tell that which one's going to which. But as these programs get bigger and more complicated, we need to start thinking about how we can make it so it's easier to figure out what's going on. So first thing we want to do is we want to give a name to these pins so that it's a little bit easier to see. So what I'm going to do up top here, I'm going to create some variables, and we have different types of variables that we can create. The most basic one, probably the one that you're going to use the most when you're working with your Arduinos, is the integer data type. So it's integer like that, and basically this is any number that's not a decimal number. It can be negative, it can be go up to billions and trillions, but it cannot be like 1.2 or 1.5. It can only be 1, 2, 3, 4, 5, only whole numbers. Okay, and how we create an integer data type is we say int, int, and you can see that it turns kind of purple. That tells me that I've entered it correctly, and the system recognizes it as a data type. So I'm going to create two variables of type integer because my pins are integers. That's why I'm using integers. And you'll see why in a second. But I'm going to create one that's called red LED. Okay. Now I can put that. It's fine, and that's been created, and it's waiting for a value. At this point, it has no value, so it's just what we call null or no value. And so it's okay, it's not that useful to us yet. But one thing you'll notice when I named it red LED. So this name has two words in it, red and LED. We're going to treat LED as one word. What you'll notice how we do this, and you'll see this kind of follows through whenever we have variables that have two-word names in it, we don't put a space. It won't like it if there's a space, so if I start the simulation, it doesn't like that. So I'm going to make that one word, and what I do is I put the first letter of the first word is lowercase, and the first letter of the second word is lowercase as well, or uppercase. So you can see here, I'll give you an example. So we have pin mode. This is the mode of the pin. The first letter is lowercase, and then the second word is capitalized, just the first letter. And you see the same thing happens here, lowercase d with a capital W. And that's just something that programmers do, and it's just how it's done. Makes it easier to read. You know when it's a variable and when it's not. So I'm going to give this this variable red LED a value. And so what I can do now is I can say I'm going to make it equal to the pin that it's plugged into. So the red LED is plugged into 7, so I'm going to make it equal to 7. So equals 7. There we go. And I'm going to create another variable called blue LED equals, you guessed it, it's going to be 6 because my blue LEDs are plugged into pin 6. And you're probably like, what is going on? Why are you doing this? And the reason I'm doing this is because what I can do is I can substitute everywhere that it says the number 7, I can substitute in red LED. And for pin 6, I can substitute blue LED. And I'm going to start the simulation, and it works fine, and it works just the way that it did before. It's flashing. Okay? Great. So now what I can do is I can go through and I can just replace everywhere that it says 7 with red LED, because as far as the computer is concerned, 7 or red LED is the same as putting 7. And blue LED for 6 and blue LED. Now what this does is this makes it really easy for me to see which one's being turned on and which one's being turned off, rather than just seeing a number and I have to go back and look, okay, which one is this plugged into? I know that the digital right, the blue LED here is being turned on, and the blue LED here is being turned off with a delay in between. Okay, so that's one variable that we've created. Great, that looks a lot better. It's a lot easier for me to read this. But another way that variables can be very useful is when we have a value that we want to change, and we have it, for example, we have 4 delays here, okay? 4 delays, and they all have the same value, okay? Now, if I wanted to experiment and try different rates of flashing, okay, what I might do is I could split this into 2, or I could just say all at the same time. So I'm going to create another integer, okay, called delay. And I'm going to say it's 500. Okay, so now I'm going to change these all to delay. Oh, actually, we may have a bit of an issue here because this is a name of a function, which we're going to learn about later, but not really a good idea to use the same name. So I'm going to change this. I'm going to call it time delay. There we go. So I'm going to call it, and you notice how I have the first letter lowercase, second word, first letter is uppercase. So I'm going to change this to time delay. Time delay. And finally, time delay. Time delay. Okay. Now if I run this, it'll be exactly the same. Okay. You won't notice any difference. Still doing the same, half second on, half second off. Okay. And that's fine because I've made it equal to 500. But what I can do now is if I want it to flash faster, all I have to do is just change one value here, and now my flashing is faster. I don't have to go and change all of these values. I don't have to change it 4 times. I just have to change it the once. So I can make this, let's make it 100. I can experiment very quickly and very easily with the different values. Now you can see that this is looking a little bit closer, okay? So now let's do a little bit more functionality here, okay? So what I can do is I can change this to time delay on, and I'm gonna copy and paste this, and I'm gonna say time delay off, okay? So now when the time is on, that's my time delay on, and that's time delay off. Time delay on and time delay off. Now what this does for me is that I can change these independently. So right now it'll be the same as it was. It'll be flashing very fast, okay? But what I can do is I can change, okay, my time delay, I want it to stay on for half a second and then be off for 1/10 of a second, right? So on for half a second, off for 1/10 of a second. And so we're going to see what that looks like. Okay. So it looks a little different. So let's reverse those. See what that looks like. There we go. Now we're getting a little bit of a Could be a little bit more of a police siren. Okay, so you can see how by using variables, we accomplish two things. Okay, we accomplish making our code more readable, meaning it's easier to go back and look at maybe mistakes that are happening, because remember, we have two types of mistakes when we're coding. Okay, we have we could have some hardware problems, meaning our things aren't wired correctly, but we're going to pretend that our wiring is fine. But in our code, okay, we have two types of errors. We have syntax errors. Those are ones where we're missing a semicolon and it doesn't compile. Okay, those ones are easy to fix, relatively easy to fix. They can be kind of annoying, but it'll tell us when we fixed it. The other error that's not as easy to detect is what are called logic errors. And logic errors happen when the computer compiles it, meaning the computer doesn't find anything wrong with the code, but the code isn't doing what we want it to do. And those can be a little bit more tricky to diagnose because there's nothing, we have to do a little bit of investigative work. And by doing this, by setting up variables, that helps us in that investigation work, because believe me, as these programs get more complicated, you need to make it readable. Okay, you have to be able to go back and see what's going on with the code. And this does that. So this allows us to say, okay, so digital write, red LED is turning on. Okay, so I don't have to go back and reference pin numbers. It's more in natural language. It's more human readable language for me to see what's going on. Okay, so when you do your code, I want you to start using variables and be able to have your code fill them. Try to avoid using numbers outside of up here. And also another thing that the variables allow us to do is to change values very quickly in multiple places, right? So we might have this littered throughout our program, and if we want to change that with the old way, we would have to go through and change each one individually. This way it makes it really quick and easy to make changes and do testing. Okay. All right, thanks for listening and hope that made sense.